Welcome, welcome, welcome to our final CSEC Math Review Marathon session this evening. Okay, this evening we will be looking at vectors and matrices. If you're going to write the CSEC Math exam tomorrow, then right here on Jumpstart Institute, live here on YouTube is the place to be. Okay, so I'd like you to share this live with your classmates, with your friends, whoever you know who is writing the math exam tomorrow. Okay, I want you to share this link with them. Don't keep all the fun to yourself. Don't keep all the information to yourself. Sharing is caring. Okay, so share the link so that we can test our skills on vectors and matrices for tomorrow. Okay, so go ahead and type a Y in the chat if you can hear me, because I'm here talking. I'm not even sure if you can hear me. If you can hear me and you can see clearly what's on the screen at the back of me here, type a Y in the chat. Type a Y in the chat. Okay, great. So Jenny typed a Y, so Jenny can hear me, and Jenny is here. And Johnny Griffith is here and ready to test their skills on vectors and matrices. And Omega Andrew is here, ready to test their skills on vectors and matrices for tomorrow. Okay, so as I said, go ahead and share. Let your classmates know that I am on. Okay, and we're going to put our skills to the test. Okay, for those of you who are joining for the first time, I am Miss K. George, the CEO and founder of Jumpstart Institute, an online learning institution. Okay, our mission is to improve academic performance across the Caribbean through technology and to empower the students through technology. Okay, so we use technology during our online classes. We use technology during our live sessions like this. We also use technology to empower students through our digital study guides that we have available for our students. Okay, if you visit our website at www.jumpstartinstitute.com. Okay, this is our website right here. Once you get onto the website and you scroll down, you will see that we have available our CSEC Math, our complete digital study guide for CSEC Math, as well as CPA Math. Once you click on Unlock the Success for $39.99. So if you know you need a crash course tonight, this is the course that you must have. Okay, once you get on there, you will get access to two sections, part 1 and part 2, which takes you to all the key concepts that you need to know: computation, consumer arithmetic, algebra, trigonometry, vectors and matrices. And you will get access to our animated videos covering very similar exam type questions, clear, concise explanation. Okay, if you need a crash course, then this is where you need to go, to www.jumpstartinstitute.com. Okay, so as I said, this evening we'll be looking at vectors and matrices. And for those of you all who do not know, but we had 3 sessions previously. So after this game, you can go to our previous videos. We have one live session on functions. We also have another session which took place on factorization. Okay, and we also had a session which took place on graphs. So if at all you want a little mini session on these topics, you can go to our previous videos and you will see these topics and you can play the game. If you do want a copy of the link to the previous game, you can send me or send the business a WhatsApp message. I'm going to type the number in the chat. I'm typing the number in the chat. Once you message me and you tell me CSEC math marathon, then I will just send you the links to the previous game. But at the end of this game this evening, I will just put the link in the chat so that everybody could have that, so they could practice the game again in preparation for tomorrow. Okay, I won't keep you all waiting any longer. I'm going to start the game right away. So I'd like you all to go to www.kahoot.it. Okay, www.kahoot.it. Okay, let me see here. One second. Someone is messaging and they wanted some information here from me. Okay, so while I'm here doing this, go ahead and share with your classmates. Let them know that I am on and I'm ready to begin. Okay, let them know that I am on and ready to begin. Okay, go ahead and share. Go ahead and share. Go ahead and share the link. Let them know that I'm going to be playing vectors and the game is based on vectors and matrices. Okay, the game is based on vectors and matrices this evening. Let's see here. Okay, all right, so I'm going to start the game. Allow me to just start and then I will give you all the game link. Okay, so the game is loading right now. Once I give you all the game link, you can go ahead and enter the game code and then you enter your name. You don't have to put your actual name. You could put a nickname. And for those of you all playing for the first time, if let's say, for example, you make a mistake, you're the only one who is going to see that error. Oh, and I forgot to tell you to subscribe to the channel. You need to subscribe to the channel. Subscribe to the channel. Subscribe. Okay. Subscribe and share. Subscribe and share. Okay, so here's the game code. I'm going to type that in the chat. The game code is 4504389. 4504389. I'm going to type that in the chat. So I'm sending that in the chat. I'm going to pin this message in case someone else comes in. So you guys go to www.kahoot.it and then you enter the game code 4504389. 4504389. If at all you're having any challenges while we are playing the game, okay, if at all you're having any challenges while we're playing the game, feel free to just put your answer in the chat. That's okay. All right, so I am going, let's see how many persons we have on here. I have 20 persons on here and I see 14 persons on the game. So let me just give the others a chance. Okay, so I see, let's see here. I see Mikey online. I see I win there. Top G is there. Kai Kipo. I can't even pronounce some of these names. Ionese, Imperial Maiden, and Kiki. And everybody's here and ready to play. I see Ami just joined. Kai-san just joined and they're ready to play. Okay. I know that you all are on. I know that you all are ready for this exam tomorrow. So here you're just going to put your skills on vectors and matrices. You're just going to test it out tonight. We're just testing it out. Okay, so if you have anything that you need to brush up on, we're just going to brush up on it right here at Jumpstart Institute. Okay, so I am going to start the game. If you all are ready, type a J in the chat. J for Jumpstart Institute if you are ready. If you are ready, Melissa, I see you. Melissa Lando, yes, I see you. Good day, good day. So Melissa, this is just a sample game of what we will be playing when you join the class come September. Okay. Okay, so let's see here. Okay, so you all are ready and good to go. Okay, so let's begin. Good luck to everyone. The following two matrices are conformable for multiplication, meaning that yes, we can go ahead and multiply these two. Can we go ahead and multiply these two matrices as they are? Okay, so in order for us to know if the matrices are conformable, meaning that we can multiply them, we need to look at the order of the matrices, okay? And when I say order, I'm referring to the number of rows and the number of columns in this matrix. Whenever we are writing the order of the matrix, you always begin with the rows and then columns. Row and then columns. So here in this first matrix, how many rows do we have in this first matrix? You all can type in the chat for me. I can see the chat. How many rows do we have in this first matrix? I want you all to help me to get the order of this matrix. Because if we do not look at the order of the matrix, we cannot tell whether or not we can multiply them or whether or not they are conformable. Okay, so Michelle said 2, and that's correct. We have 2 rows in this matrix. So remember, the order always begins with the row. So we have 2 rows. So this is a 2 by, and we have 2 columns as well. So this is a 2 by 2 matrix. What about the second matrix? What is the order of this matrix? Meaning the number of rows by the number of columns. You all can type that in the chat for me. The order of the second matrix right here. Remember, the row comes first, and then you write the multiplication. Well, it's not really a multiplication sign. It means by. You're right. Okay, excellent. 2 by 3. So the second matrix is a 2 by 3. How do I know that these two matrices can be multiplied? I simply look at my inner numbers here. You see these 2 numbers on the inside here? They are the same. So this means that yes, I can multiply these 2 matrices. So in order for you to be able to multiply them, the first matrix, the number of columns in the first matrix, must be equal to the number of rows in the second matrix. Okay? So as you can see here, once the 2 inner numbers are the same, then yes, you can multiply them. Okay, so let's look at the second question. Okay, yes, Nathan, 2 by 3. You are correct, Nathan. I see that. Okay, so let's look at the second question. I see Imperial and Spards and Missionaries at the top climbing. Okay, let's see. The order of the following matrix is, what's the order of the following matrix? Remember, row by column, row by column. Remember, row by column. Okay, so let's see here, looking at this matrix, we had 3 rows and 2 columns. So this was a 3 by 2 matrix. Remember, rows and then columns. Okay, so I see KK here flying to the top and Imperial. Okay, let's move to the next question. Okay, so given the following statement below, matrix B is A inverse. Is that true? Is A times A inverse equal to this matrix here? Is A times A inverse equal to this matrix? This matrix here is a special matrix called the identity matrix for 2 by 2 matrix on the multiplication. So when we multiply A by A inverse, right, so this is correct. So I'm happy to see that 15 out of 17 persons got this correct. Excellent. Okay, so class, whenever we multiply a matrix, okay, whenever we multiply a matrix, for example, if we had matrix B, and it's a 2 by 2 matrix, once we multiply this matrix by its inverse, the result will always be, Ajani said easy, excellent, I like that. The result will always be the identity matrix, okay, on the multiplication. Okay, excellent, 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 excellent. Okay, so if I had C times C inverse will result in this matrix, this identity matrix on the multiplication. Okay, let's move on to the next question. Okay, so I see Jewel is the highest climber, trying to climb up. Let's see here, Jewel is trying to climb up. Congratulations to all those on the screen so far. You all are working for that grade 1 tomorrow. I see you all are ready. The determinant of the matrix shown below is, so here we have a matrix. How do we calculate the determinant? Take note of your signs. Take note of your signs. Okay, take note of your signs. How do we calculate the determinants? Just to remind those of you who are here wondering, the determinant is the difference, difference meaning subtract, the product, product meaning multiply, of the product of the leading diagonal from the non-leading. And I'll explain to you what this is when we end this question. Okay, so the answer was 17. How do we calculate the determinant of a 2 by 2 matrix? We calculate the determinant by saying the difference, meaning we are going to subtract, okay, the product of the leading diagonal. What's the leading diagonal? You want to begin in the first element in the first column, first row. So we are going to begin with the 3, and you multiply the 3 by the 5. Okay, so we say 3 times 5. So the product of this minus negative 1, sorry, times positive 2. Negative 1 times positive 2. So we always begin with the first, in the first row, first column. So we multiply the 3 by the 5 minus the negative 1 multiplied by 2. Now 3 times 5 would give us 15 minus negative 1 times 2 would give us negative 2. These two signs in the center, two negatives. Remember I told you that how many times? Only in math, 2 wrongs make a right. So 2 negatives, that becomes a positive. 15 plus 2, that would equal to 17. Okay, I would like you all to help me to calculate the determinant of this matrix. I'm going to put another one on the board here. So here I have this 2 by 2 matrix. Let's say the elements are, let's say 1, 6, negative 2, negative 3. What do I multiply first? Should I say negative 2 times negative 3, or should I say 1 multiplied by 6? I'm trying to calculate the determinant. Where should I begin? Should I begin by saying 1 times 6, or should I say negative 2 times 3? Type the answer in the chat for me, please. I need you all to help me out here. I'm trying to calculate the determinant of this 2 by 2 matrix. Okay, so chicken backs. I know that's not the name your mom gave you, but yes, you all are correct. So we always begin in the first row, first column. So we say 1 multiplied by 6 minus negative 2 times negative 3. Okay, so we are calculating the determinant here. 1 multiplied by 6 gives me 6 minus negative 2 times negative 3. Again, 2 wrongs make a right, so this would give me positive 6. 6 minus 6 is equal to 0. Okay, so as you can see, the determinant for this matrix is equal to 0. I would like you to note at this point that whenever the determinant of a matrix is equal to 0, we say that this matrix is a singular matrix. It is singular. Okay, singular. If the determinant is equal to 0, it is considered to be singular. If the determinant is not equal to 0, okay, so if it is not equal to 0, we say that it is non-singular. Okay, so for the exam, they may ask you, prove that this matrix is singular. To prove that the matrix is singular, you simply calculate the determinant and you show them that the determinant is equal to 0. Once it is equal to 0, then yes, it is singular. Okay, so let's move on to the next question. Okay, I see you, top G. Is the matrix shown below singular or non-singular? remember, to determine whether the matrix is singular or non-singular, you have to calculate the determinant. If the determinant is equal to 0, the matrix is considered to be singular. So calculate the determinant, and once you get your answer, you will be able to identify whether the matrix is singular or non-singular. Okay, excellent, excellent. Most persons got this correct. So yes, the determinant was 0 because 1 times 2 gave us 2, and it was the same either direction. 2 minus 2 gave us 0. Okay, Imperial, look, I see a new person name on the new names on the screen, so it tells me that every wrong, I am seeing new names. It tells me that you are ready for this exam tomorrow, at least for the vectors and matrices section. Now here we are going to apply a little algebra. The determinant, I am already telling you that the determinant of this matrix below is 13. So the determinant is 13. I want you to calculate the value of x. So you're going to calculate the determinant the same way. You start with the first row, first column, you multiply diagonally minus the product of in the other direction. Okay, and then you solve for x. You solve for x. Okay, so the person asking the question in the chat, someone just asked, if a matrix is singular, does it mean that it has no inverse? You are correct. Once the matrix is singular, meaning that its determinant is 0, then you cannot find the inverse. Because to calculate the inverse, you have to say 1 over the determinant multiplied by the adjoint of the matrix. And once the determinant is 0, 1 over 0, then you cannot find the inverse. Okay, so chicken box, again, I know that's not your real name, but no, you cannot find the inverse of a matrix which is singular. Okay, so let's get back to the question here. So let me see how many persons got this correct. Okay, so 7, that's almost half of you all got this correct. So the question said that the determinant of this matrix is equal to 13. Okay, what is the value of x? So we are simply going to go ahead and calculate the determinant. We begin here and we say x times x. What's x times x? Could you all type that in the chat? You can write it out in words if you cannot put the symbol. What is x multiplied by x? Please do not tell me 2x. What is x multiplied by x? You can type it in the chat. X to the power of 2. X to the power of 2. Excellent. So we are calculating the determinant because they tell us the determinant is 13. So x squared. Now to calculate the determinant, we minus and we say 4 multiplied by 3. So we have 12. And all of this, which is the determinant, is equal to 13. But now they asked us for the value of x. So here it is that we are solving for x. To solve for x, we want to remove the 12 and bring it to the other side of the equation. And then we want to move the little square that's above by the x and bring it to the other side of the equation. We always begin to move the terms that's furthest away from the variable. So we are going to move the 12 by doing the opposite of what is being done. Because the 12 is being subtracted, we are going to add 12 on either side of the equation. So here, this 12 is cancelled. So now we have left x squared is equal to 13 plus 12. That gives us 25. Now I have a question for you all. How do I cancel this square? How do I get rid of this square that's above by the 2? I want to remove this little 2, this square that's above by the 2, and bring it to the other side. The opposite of subtraction is addition. The opposite of multiplication is division. So what's the opposite of square? Excellent, Alanis. Excellent, Journey. Excellent, chicken backs. Every time I keep saying chicken backs, I'm laughing in my mind. Square root. Excellent. So for us to cancel this square, we are going to square root on either side of the equation. Square root of 25, that's 5. So x is equal to 5. Here it is that we have our solution. Let me bring this up so you can see that x is equal to 5. Okay, so let's move on. We are moving on. And we are also going to look, KK is at the top, just flying up there. I'm seeing, who is this? Nick slash her is the highest climber, just climbing. Okay, so let's see. So now we are looking at vectors. So zoom in on this diagram. And I want you to tell me what is a column vector. Okay, so let's see here. Okay, so 13 persons got this correct. That's quite a bit. Excellent, excellent. I'm giving you all some confetti for this. Okay, so the vector here, this vector is a position vector because it starts at the origin. Okay, I'm going to try my best to draw a straight line. So whenever you're writing the vector as a column vector, the first number is a horizontal movement, okay? So the vector was vector what? OS? I'm assuming that it was S at the top here. So vector OS, so this means that we are starting at O. So remember, the first number is a horizontal movement. So to get from O to S, we first had to move to the left, 1 unit to the left. Because we are moving to the left, we say -1. Had it been to the right, we would have said positive. Then the second number is a vertical movement. So we are moving upwards 4 units up. And because it is an upward movement, it is positive. Okay, so -1, 4. If it was a downward movement, it would have been negative. So again, the first number, horizontal movement, left, negative, right, positive. The second number, vertical movement, up, positive, down, negative. Okay, let's look at our next question. Okay, so I think the next question, I think it is the same diagram. We are looking at the other position vector. So they're asking for the column vector for OQ. And this is a past paper question, yeah, by the way. I think that was a 20. I can't remember which year, to be honest. Either the 2021 or 2022, one of these. Okay, so I took this straight from the past paper. What is vector OQ? Okay, again, remember the first number, horizontal movements. Second number, vertical movements. Okay, excellent, excellent. 17 out of 18 persons got this correct. You all are ready for the vectors and matrices section of that exam tomorrow. You all are ready. Okay, excellent, excellent, excellent. So just I don't like to leave anybody behind. So just to make sure, so from here, position vector, okay, we want to write as a column vector, movement horizontally, 1, 2, 3, 4, 5 units to the right. So the first number was positive 5, and then 1, 2 units up. So the second number was positive 2. Okay, let's get back to the game. We are on to the final question of the evening. Given vector OS below, what is vector SO? So here we have the column vector. So now it's going in the opposite direction. Here we have vector OS. I'm asking you for vector SO. Okay, excellent. Majority of you all got this correct. So as you see, once the vector changes its direction, you simply change the sign of the numbers in the column vector. Okay, that vector here was vector OS was what? Negative. Vector OS was negative 5, positive 2. Okay, so vector OS, I'm trying my best to draw a straight line here. Okay, so vector OS. Okay, as you can see, vector OS, we had to move from O to get to S. We would have moved 5 units to the left and 2 units up. So 5 units to the left, vector OS would have been negative 5, positive 2. That's what was given to us. But now vector SO, now we are starting at S. To get back to O, remember the first number must be a horizontal movement. So vector SO, starting at S, we're trying to get back to O. So we are going to move on towards the right now. Okay, 5 units to the right. So that's positive 5. And then 2 units downwards. So that's negative 2. But as you can see, once we change the direction, we simply changed the signs of the numbers in the column vector. Okay, I think you all did an excellent job. If you know that you're going to crush the exam tomorrow and you're going to get a 1, I want you to type a 1 in the chat for me, please. Type a 1 in the chat if you know at least the vectors and matrices section. Type a 1 in the chat. You have to believe that you're going to pass tomorrow for you to pass. If you do not believe, a 4, no, Stephen, you cannot claim that. You cannot claim that. I rebuke that. No, no, no. 1, only once tomorrow. Yes, in the mighty name of Jesus. Yes, chicken backs, in the mighty name of Jesus. We are getting a 1 tomorrow. We are claiming it by the grace of God. Okay, we are claiming that 1 tomorrow. We are claiming it. We are claiming it. We are claiming it. It's rough. You have to put in the work. You have to put in the work for it to get the result. Faith without God said that faith without works is dead. You can pray, yes, but you have to put in the work. Okay? And even if you're working, you have to pray as well. So make sure you all pray this evening before you go to bed, and pray before you do the exam. Say a little prayer. Okay, so let's get back to the game. Okay, you all are all winners in my eyes. You all are all winners, but we have 3 persons on the podium this evening. Imperial Maiden, 3rd place, Top G, 2nd place, and the 1st place we have KK. Okay, so excellent. And we have Carl and Mikey. Okay, I want to give you all I want to send the link for the game for you all. I wasn't ready. Can we rewatch? Okay, I'm going to send the link for the game. I am going to send the link for the game. Okay, so just hold on 1 second here. I am going to send the link. I think I already assigned. That's okay. I am going to send the link for the game so that y'all can... I am going to remove the timer on it, so that you will have time for you to work it out at your own pace. Okay. So I'm just going to copy the link here. I'm going to send this in the chat. Okay, so you can, I just sent it, so you could just copy this link and you could play this game at your own pace, on your own time, in preparation for tomorrow. Okay, remember to subscribe to the channel. Subscribe. We do have the videos from the previous live sessions on functions, factorization, graphs, and this evening we looked at vectors. So you can go back to the other videos. Make sure to like the video and subscribe. Okay, and you can always share this channel with your friends, and those who are in Form 4, you can share this link with them and tell them that this is the place that they need to be. And especially for those who would like online classes, we do have online classes available. Registration begins in June. Space is limited because I do not like the classes to be too large. Okay, so I wish you all good luck. All the best tomorrow. By God's grace, you will pass the exam. Remember to pray. Study, yes, but pray as well. Okay, so have a blessed evening and good luck tomorrow. Bye. Bye. All the best on your exam tomorrow. All the best. You are welcome for all the live session. You are welcome. You are most welcome. I'm happy to help and happy to make a positive impact on y'all's lives. Okay, so pay it forward. When you get out of high school, also continue to have a positive impact on someone else's life. Sorry. Okay, so bye. You're welcome, Keisha. Bye.